Hi everyone. Today we are going to see the subject kinematics of machinery. In that we are going to see Unit 1 Basics of Mechanics. Before that we need to understand what are the topics we are going to see in this kinematics of machinery subject and what is meant by kinematics of machineries. My name is Chandru, Assistant Professor. This is a subject name ME8492 Kinematics of Machinery. In this subject we going to understand the basic concepts and the layout of linkage in the assembly of a systems, to understand the principle in analyzing the assembly with respect to the displacement, velocity and acceleration at any point in a link of a mechanism, to understand the motion resulting from a specific set of linkages, design few linkages mechanism, cam mechanism for a specified output motion, to understand the basic concept of toothed gear and kinematics of gear train and the effect of friction in motion transmission and in machine components. Totally we have 5 units. First unit is basics of mechanism. Second unit is kinematics of linkage mechanism. Third unit is kinematics of cam mechanism. Fourth unit is gear and gear train. And the fifth unit is friction in machine element. Today we are going to see first unit. Basics of mechanism. What is mechanism? What is engineering mechanics? Then only we understand the real concept of kinematics of machineries. Mechanics is the branch of science which deals with the behavior of an object at rest or in motion under the influence of force. Engineering mechanism involves the basics of the principle of mechanism to solve real-time engineering problems. The figure shows the mechanism, how the mechanism will act in it. Before that, we need to understand what is a theory of machines. The subject theory of machine, also known as a mechanism of machines, comprises the study of relative motion between the parts of a machine and the force which act on those parts. It is understood that most mechanical engineering activities revolve around mechanical systems whose function depending on the relative movement among its various members. The design of a mechanical system need a proper understanding the geometrical aspects of a motion and various force involved in motion. The theory of machine subject tries to provide underlying theory and the scientific principle behind the behavior characteristics of all machines and mechanisms. The major objective of the subject theory of machines are to provide the engineer to necessary tools to symmetrically synthesize systems. The theory of machine subject may be divided into kinematics of machinery and the dynamics of machinery. In engineering mechanics, it basically divided into two: mechanics of solids and mechanics of fluids. Rigid body, mechanics of solids is furtherly classified into two types: rigid body and deformable body. What is meant by rigid body? Rigid body is nothing but it does not occur any deformation while the external force is applied on it. Deformable body means it affects while the external forces applied on it. Rigid body is furtherly classified into statics and dynamics. In dynamics, it is classified into kinematics and kinetics. What is meant by kinematics? Invented by Nicholas Orme, represented time and velocity by length. It is the study of motion without addressing any of the force that caused the motion. It is called as a kinematic. It does not consider any force acting along it. What is meant by machine? Machine originated with the Greek philosopher Archimedes around the 3rd century, who studies the simple rigid or resistance body, force and connected to that. They move with definite relative motions and transmitted forces from the source of power. A machine has two functions: transmitting definite relative motion and transmitting force. This is the two functions occurred in the machines. What is meant by kinematics, links and elements? Each part of a machine which moves relative to some other parts is known as kinematic links. A link or element need not to be rigid. For example, piston connecting rod is the best example of a kinematic link. Next, we are going to see what is the types of link. Rigid link. A rigid link is one which does not undergo any deformation while transmitting motion. For example, piston and connecting rod. While we applying a force in a piston and a connecting rod, only it transfers the motion between the two parts, but it does not deform in any circumstances. It is called as a rigid body. What is flexible ring? A flexible link is one which partly deform in a manner not to affect the transmission of a motion. For example, belt, rope, chain and a wire are a flexible link and transmitting tensile forces only. Next one is fluid link. A fluid link is one which formed by having a fluid in a receptacle and motion is transmitted through the fluid by pressure or compression only. In case of hydraulic press and jack and brakes, it is called as by using transmitting a force between the parts. Structure. What is meant by structure? It is an assemblage of a number of resistance body known as a member, having no relative motion between. A railway bridge, a roof truss, machines frames, etc. are the example of a structure. What is the difference between machine and a structure? The part of a machine moves relative to one another, where the members of a structure do not move relative to one another. A machine transfers the available energy into some useful works, where in a structure no energy is transmitted into useful work. The link of a mechanism may transmit both power and motion, while the members of a structure transmit forces only. Next one is the important topic. What is the kinematic pair? The two links or elements of a machine, when in contact with each other, are said to be a form of pair. For example, connecting rod and connecting piston. The connecting rod is connected with a piston to transmit a power. Crank and connecting rod is also a best example for a kinematic pair. Types of constrained motion. It is classified into three types. First one is completely constrained motion. When the motion between the pair is limited to a definite direction, respectively of a direction of a force applied, then the motion is said to be a completely constrained motion. I repeat it once again. Completely constrained motion. When the motion between a pair is limited to a definite direction, irrespective of a direction of a force applied, then the motion is said to be a completely constrained motion. Here we see the example of completely constrained motion. Square bar in a square hole. Shaft with the collar is also another example of completely constrained motion. In completely constrained motion, when the motion between a pair can be takes place in more than one direction, then the motion is said to be incompletely constrained motion. For example, shaft in a circular hole moves in both front and back, and it capable of to roll. It is said to be incompletely constrained motion. What is successfully constrained motion? When the motion between the element forming a pair is which the constrained motion is not completely by itself. but by some other means, then the motion is said to be successfully constrained motion. For example, the motion of an IC engine valve, these are kept on their seat by the spring, and the piston reciprocating inside an engine cylinder, also known as an example of successfully constrained motion. In our next video, we are going to see classification of kinematics pair. Thank you.